Hi, this is example number 5. This is a special case of plane stress. So in this example, we're going to go back to our previous example we just did, example 4, and I'm going to do a very small variation to it. Okay, so let's suppose I have this example, minus 20, 30, 30, 10, 0, 0, 0, 0. And let's suppose I put a 5 here. Okay, this is not a case of plane stress. It's not plane stress. But to solve this problem it's kind of easy if you can see that all these are 0, right? Have only one number and it's across the diagonal, then your solution, remember that we had lambda squared minus I1 lambda plus I2 equal to 0, right? And I told you what you could do is you could solve this and say lambda 1 and 2 was equal to sigma average plus minus sigma difference squared plus tau xy squared. So what we're going to do is, this is still true. All you have to do is say minus 5, whatever this value is, you put it inside here. So now one solution, lambda 3, instead of being 0, will be 5. Okay? So the problem will not change at all. These values still will have the same values as before, 28.5 and minus 38.5. The only value that's changing is this number here. If I had the same problem and I did minus 20, 30, 30, 10, 0, 0, 0, 0, minus, let's say, 10, in that case, it will be lambda minus 10, and you still solve this using this equation, right? Plus lambda 2 equal to 0, I2. I should warn that these I2s are a little bit different now, but there's not a problem because you know how to solve this. Use this. The solution to this is actually given by this equation that I gave you in class. And then here, one possible solution would be lambda is equal to minus 10. Okay, how do I do this? Well, you can see that this gives you lambda plus 10. Okay, so you say lambda plus 10 has to be 0. Remember, this has to be 0. So this has to be 0 and this has to be 0. And this gives you 10 is lambda is equal to minus 10. So you still, these solutions remain as we had before, 28.5 and minus 38.5. The only thing that we are changing is this value here. So these are different variations of different problems we can do. And you can see that this is not a plane stress problem. It's a special case, so for the solution itself, it's very easy to solve. So if you wanted to do this in MATLAB, once again, let's solve this. It's inches, it's KSI, is minus 20, 10, minus 10, let's do this last problem. This is 30, 0, and 0. you can see now one of the solution is minus 10. So you shifted from 0 to minus 10. And the other values are identically the same. Nothing else changes. These values will change, obviously, because this got shifted. But the overall value remains the same. Okay, so this is one case. We could have many different variations of this. What if we had a case of sigma is equal to minus 10, 0, 5, 0, 0, 0. Let me change this value here to minus 10, 5, 5, 10, let's say. Let's call this 15 just for the sake of making it different. In this case, your problem still will be the same, but the only difference is now you can see that your 0 is across this axis, so you can put x, y, z, x, y, z. So you can see this is confounded to the xz plane. Okay? So this is confounded xz plane. So your value is lambda minus this value, 5, remains the same. And lambda squared minus I1 lambda plus I2 is equal to 0. And in this particular problem, again, here lambda is equal to 5 because we said that this equal to 0. And setting this equal to 0, then you get lambda 1, lambda 2 is sigma average plus minus sigma difference squared plus tau. Now it's confounded xy, xz plane, xz squared, where sigma average will be sigma xx plus sigma zz divided by 2, and sigma difference will be sigma xx minus sigma zz divided by 2. So you can see that you just have to pay attention to where your stresses are confounded to, and thus the answer you get. This concludes your last example, example number 5 of plane stresses.